Hi, my name is Caroline, and today we'll be discussing the science of swimming. There's a lot of science behind swimming efficiently, which makes this sport key to learning a great deal about the intriguing field of physics. First, let's dive into Newton's 3 laws of motion, all of which can be effectively portrayed through swimming. Newton's first law has to do with inertia and states that an object in motion or at rest will stay in motion or at rest respectively unless acted upon by an outside force. This law can be represented by the equation shown, where the summation of all forces is equal to the change in velocity. Let's take a look at a real-life swimming example that clearly represents this idea. In this clip, my friend Kristen is initially at rest, and according to Newton's first law, will stay at rest unless a force is applied. Kristen pushes off of a wall with an initial force and goes into motion. She would keep moving in the same direction, but in this case, water resistance causes her to eventually come to a stop. Newton's second law of motion can be summarized in one formula: force equals mass times acceleration. This indicates that force is directly related to acceleration, given that mass is constant. Thus, the greater the force, the greater the acceleration for a given object of constant mass. Here we see my friend Christina push off the wall with low force, traveling to the first yellow mark on the lane line with lesser acceleration. In the second clip, she pushes off with greater force and travels a farther distance, past the fourth yellow marker, in the same amount of time, showing how a greater force leads to greater acceleration. Newton's third law has to do with the equal and opposite effect. This law states that for every action, there is an equal and opposite reaction. When Kristen pushes backwards off the wall with force F, the wall also applies an equal and opposite force, allowing Kristen to move forward. Also, Kristen pushes and kicks the water backwards in order to move forwards. Now that we've covered Newton's laws of motion, let's dive into fluid dynamics, a branch of physics regarding the flow of fluids. Buoyancy, or upthrust, is a force that opposes the weight of an object in the fluid. Archimedes' principle states that if the buoyant force or weight of fluid displaced is greater than the weight of the object will float. Form drag is caused by an object's shape. Generally, a streamlined body which poses less surface area has less frontal resistance and form drag than a body with hands spread out. Frictional drag is caused by an object's surface texture. Tangential forces that result from a fluid flowing over an object cause this friction, and thus rough surfaces such as an unshaved body or a loose swimsuit invite greater frictional drag. Wave drag is caused by turbulence in a fluid. As Kristen is doing the butterfly stroke, she's generating great turbulence, as can be seen through the many splashes and ripples generated, which would make it more difficult to swim fast in the lane next to her. In addition to separating the lanes, lane lines are designed to reduce wave drag for fair competition. Thank you so much for watching.
Created using Powtoon.